Hi, welcome to Data Structure and Algorithm series by Coding Ally. Coding Ally is a non-profit organization where we believe women and gender minority should have a safe space and support system where they can foster their skills and career in tech. I'm your host, Sue. Today, we are going to solve this Leetcode 350 intersection of two array. This is the agenda for this video. First, I'm going to read through the problem statement and then go through the thought process. After that, I will go through approach 1 using the hash table and then walk through the code both in JavaScript and Java. So first, I will read through the problem. Given two integer array, nums1 and 2, return an array of their intersection. Each element in the result must appear as many times as it shows in both arrays, and you may return the result in any order. So, if we look at the example 1, you can see here that nums1 has got 1 to 2 to 1, nums2 to 2. So, the output is 2, 2. Example 2, nums1 has got 4, 9, 5. And nums2 4, 9, 9, 8, 4. So from here we can see that these two elements are common. So this is the output. From the explanation, we also know that 9, 4 is also accepted. So this is the constraint. The constraint is the length of this both array is between 1 and 1000 inclusive, and their value it's between 0 and 1000. And we've got this follow-up questions, but in this approach, I'm not going to solve this problem using the optimized approach. So for that, I'll make a separate video and then I'll put the link below in the description. So let's start with this approach. In this approach, we are going to use the hash table. So as a step 1, we can initialize the hash table called nums1 map for the nums1 array to store the element. So it is a map, so we are going to store the key value pair. Key as in the element, value as in the frequency of the occurrences of each element. Step 2. In this step, we can initialize the result array, which will hold the elements that intersect in both arrays. That is the result that we are going to return. Step 3. In this step, we can iterate through this nums1 array and then add them into this map. If the element is already present in the map, then we can just simply increment the frequency. Otherwise, if the element hasn't been added, then we can add the key and the corresponding value as 1. This is the last step. In this step, we need to iterate through this nums2 array and check whether the element is found in the key of this map. If the key element is found as key, then another condition is the corresponding value is greater than 0, then we are going to push that element into the result array. After that, we need to decrement the value of that key because we have used that frequency, the value to push that key element into the result. So in here we have we are iterating through nums2 and at the end of this num2 the element is 2 and we check nums2 do we have 2 in this map? Yes, we have. And then we also check for the value. The value is 1, which is greater than 0. So now we can push this key into the result. So now the result is 2, 2. After we push the key into the result, we have to decrement the value in here, which is what we've done. So 2 corresponding value is 0. So this is the summary of the thought process that we went through. I will briefly summarize again. Step 1, we will initialize the hash table so that we can go through the nums1 array and to store the element as key and their corresponding frequency as value. Step 2, we'll initialize the array that will hold the elements that intersect both arrays. Step 3, we will iterate through nums1 array and add them into the map. If the element is already present in the map, then we can simply increment the existing frequency value. Otherwise, then we will add 1. In step 4, we will go through the nums2 array and we check if the element is found in the key. If there is, and also the corresponding frequency, the value is greater than 0, we push that element into the result. Otherwise, after that, we will decrement the value of the key. So before I dive into the JavaScript solution, I want to go through these 5 methods which are highlighted in this pink color, 1 to 5. So we need map. For map, this map object will hold the key and value pair. So we will use this map const map equal to new map. And then we can iterate through this array. For the map, we will use 3 methods from 3, 4, 5. Map.set, it will take 2 arguments, key and value. It will store the value by the key. Map.has, this number 4, it will take only 1 argument key. It will return true if the key exists, false otherwise. 5, map.get, the only argument is key. It will return the value by the key and define if the key does not exist in the map. Let's have a look at the code. This is step 1 and 2. We have initialized the map. We have also initialized the result. Step 3. We are iterating through this num1 array and we check in the map. If the map has got this element, we are going to set the value, key, and the value we increment 1. Otherwise, then we are going to set the element and we simply add the frequency 1. This is the last step. In this step, we will iterate through every single element in the nums2, and there are 2 conditions we check. Map.has, if the map has got this element, and also the frequency, the corresponding key frequency has to be greater than 0. In that case, we are going to push that element into the result array. After that, we need to set this map, the value, and we have to decrement the frequency. That is what we have done here. And then by the end of this loop, we will get the result that has all the corresponding elements that are all the intersecting element in both nums1 and nums2 array. So let's have a look at time and space complexity. Time, space complexity, the first line. We are initializing the new map. So for that, we use heap memory. So in worst case, it's O of n. Result is part of the result array, is part of the answer, part of the solution. So we don't need to count that. For runtime, for this block of code, going through that nums1 array, in worst case, O of n. Nums2, this block of code, iterating through every single element in nums2, and we are looking things up. Lookup in map is constant O of 1. However, going through every single element in nums1, it will cause O of n. So overall time complexity is O of n. Overall space complexity is also O of n. Next, I would like to go through Java. To implement this solution in Java, I've used, from this Java collection framework, I've used the array list and hash map. So these are the 6 Java methods that I'm going to use in this problem. And hash map is very similar concept to JavaScript. In here, instead of using the integer primitive array, we don't know how many elements that we will find that intersect both array. So for that, we have to use that dynamically sized array. So for that, we have to use this array list. Map.put is same as map.set in Java. Map.contains key is same as map.has in JavaScript. map.get is same as map.get. They both are exactly the same. So let's have a look at their solution. Step 1, we initialize the map using hashmap. Step 2, we initialize the result array, and it is a dynamically resizable array. Step 3, we are going through every single element and we first check if the element has if the map has got this element. If that is the case, we are going to put it key value pair and we increment by 1. Otherwise, we will add that key and then we will add the value as 1. This is the last step, second last step. In this step, we are iterating through the elements in nums2 array. There are two conditions that we check. First condition is this map needs to have the when we look up, we need to find this key, and also the corresponding value have to be greater than 0. If that is the case, we will add it, and then after that we will reduce the frequency. So this is the extra step in Java. The reason is in the return type, as you can see, we have to return the primitive data type, primitive array. We can't return this array list. So for that, we need to change that into array list. So now we know the size of this result by getting it from result.size, and we will iterate through every single element in result, and then we will add it into the final result. After that, we will return the result. So let's discuss time and space complexity. Overall time is O of n, and overall space is also O of n. Thank you for watching. Please make sure you subscribe and press the like button if you found this video helpful. Join our weekly Wednesday Data Structure and Algorithm Night, where we organize peer-to-peer coding interview. You can find event details on our Facebook page. Thank you.